Now we move on to the topic of projectiles. Before I begin, I want to quickly remind you, you can see a link to the video on projectiles in the description. Please do check that video out. It is over an hour, but it is in detailed explanation on the topic of projectiles. The information might be useful to understand thoroughly to solve any type of problem. Now we will look into a couple of problems. Here we have, if a diving board is 4.5 meters above the surface of water and a diver starts with initial velocity of 2.4 meter per second in the upward direction, because it's positive then. What is the diver's velocity at impact assuming no air resistance? This is very crucial. What is exactly impact? Now, is already above 4.5 meters. This is the, say, the surface of the water. The impact would be when he comes and hits, the diving board comes and hits the surface. Impact. So the initial height over here is 4.5. See, this is the initial height. When the height is 0, that is called the impact height. The height of any time when it's 0, it's impact height. So now we directly can't find this. It's a long method. Now we'll see how it is. First, we don't have any equations over here, right? What do we know in general in real world? We know the acceleration due to gravity. But before that, let's write the given. We know h of 0, that is initial velocity, is 4.5. And the initial, sorry, I'm wrong, sorry. Over here, it's initial position. Okay, it's very easy to get confused over here. Now, whenever you have a distance, that's the position, only distance. Meter per second is the velocity. The initial position is given as 4.5 meter and initial velocity is 2.4 meter per second. Next, you need to understand what needs to be solved. That is h dash of t, but at t is impact time. Okay. Now we know the acceleration due to gravity is negative 9.8 meter per second square. All you need to do is integrate this and then you will get the velocity. Integration of acceleration gives you velocity, whereas integration of velocity gives you the position. Position can be written as s, or anyway, if you understand it's enough. Whereas in the previous term we had derived it. If we derive position, we get velocity. Derivation of velocity is acceleration. But now it's other way around, we are coming backwards. Now, so we found the velocity, but this velocity is general velocity at any time t. How do we find, now when you integrate it, you will have a constant of acceleration, that is c. How do you find the c? You know the initial velocity at h dash of 0 is 2.4. So instead of time t, substitute 0. All you do is h dash of 0 now. We know that value is 2.4. So substitute over here, wherever t is there as 0, and substitute this 2.4 meter per second in this case. H dash of 0 is 2.4. Right side, this becomes 0. What is remaining? C. So basically C is your, C value is the initial velocity. There is also another easy method where if you see anytime initial velocity or initial height is given, directly take that as the constant of acceleration. Constant of integration, C value. Why? Because it does not change, all the terms become 0. Only when there is trigonometric function you cannot do that, or some rare cases you cannot do that. But in general, if you have a polynomial equation, you can just take this as C. Now I hope you're clear until over here. We just took the acceleration, we know it's a constant value, integrated it, found the velocity, and to find the c we substitute h dash of 0 and find the c value is 2.4. Now we can write h dash of t is minus 9.8 t plus 2.4. Okay, we found the velocity, but is this the velocity which we want? No, we need the impact velocity. How do we find the impact? We need to derive this again, find the position now first, because then we can find the impact time. Let us integrate this not derive, I told derive, sorry, integrate this and you will get this as the answer. Now whatever integration of velocity, whatever you get is the position. Now this is useful. Why? Because we know the wait, first of all substitute this c as to 4.5 directly, or you can substitute this zeros and do it. Now we got the position. Now over here, we know that the height, the impact height must be 0. Impact means it's touching the surface, it's touching the initial base. That must be 0. So you must understand this. This is the surface of water. There's a diver who is above 4.5 meter. Impact means it's touching the surface over here. So the initial height is 4.5, but the impact height will always be 0. So h of t must be 0. Now you can solve this as a quadratic equation. All you need to do is put in the calculator and solve. If you have not, if you do not remember this, just remember, take out your calculator, press more phi 3. This is how you solve quadratic equations. Now over here, you need to just put in the coefficients 4.9, and then this is before x squared. Over here, x is not, it's t squared, it's fine. Then we have 2.4, and lastly we have 4.5, and the equations of the values are over here. Now it is minus 4.9 plus, okay, so these are the answers. It's 1.2 and 0.7, but negative. Now over here, look carefully. We are getting two values. One is positive, that is 1.23, and one more is 0.74. You cannot take a negative value because we are considering this t as time, right? We are dealing with time, the position with respect to time t. Impact time cannot be negative. So just disregard this negative value. Just take the positive value, 1.23, and that will be a time. Now, what it means is, from the beginning, when this diver jumps, the time it takes for this diver from 4.5 meter to, reach the surface of the water is 1.23 seconds. Now, if you substitute this time, that 1.2 seconds, in this velocity equation, you're going to get impact velocity, because impact means touching the surface. And we can model the time, that is 1.23 seconds, is the impact time. Now, the velocity, when solving the equation of velocity at this impact time, we get the impact velocity. That is, just put over here instead of t as 1.2 and solve it. You will get the answer. This is the impact velocity. So that's how we solve it. Now let's see one more problem. Now it's similar. You need to solve it by yourselves. Solve more and more problems. You'll be thorough with this. Over here there is an object which is launched at an angle pi by 6 from the horizontal with initial speed v naught equals 98 meter per second. We need to determine the flight and the range of projectile. Just like the previous problem, let's write the given. The angle is given and initial velocity, initial speed is given. That is the velocity. Now sketch a graph to understand better. Now there's one thing over here. There is an angle, so we need to have two different orientation. That's the velocity in the vertical and horizontal, because there's an inclination for the launch. Now over here we get v naught sine theta for the vertical side and v naught cos theta for the horizontal side, and this over here is what is the projection of that, whatever is thrown. So now to solve, we need the time of flight. That means now this object is launched from here, right? How much time will it take when it reaches over here, when it reaches the ground? And then this distance that is covered by the object. Those are the two things we need to solve. But here now it's same like the previous one. Please be thorough with the previous problem, or you can just click on the description and watch that projectiles lesson. There are many real world problems. If you're thorough with it, this will be very, very easy. Use the acceleration. Now we will deal with the vertical component first. Acceleration in the vertical is always gravity acting downwards minus 9.8 meter per second square. Now we can find the velocity easily by integrating this, nothing much. And then we got this in terms of c. What is the c value? You need to find it. Now here you can't directly assume any value. You need to solve by finding this y dash of 0. What does y dash of 0 means? Y dash of 0 means over here the vertical component, initial velocity along the vertical component, because we have theta and the initial velocity given, right? So we need to solve for it. Y dash of 0 is 98 into sine pi by 6. You need to solve that. You will get 49 meter per second. That would be the c value. Sorry, let me just go back. Okay. See, now one quick thing, when you're solving this, use mode phi, sorry, shift mode and 4 radians. And now type in the value 98 into sine of pi by divided by 6. Close the bracket. That is the answer. 49. So then what you do is you just substitute this 49 in that C. We got the velocity. Now we can find the position by integrating this. Just easily find it out. Now over here, the altitude is not mentioned. It's 0 from the base. So altitude is 0. So this is not there. This is basically the initial position. That is with regards to the vertical. Now, how do we find the time of flight? Basically, we know if you throw anything, throw an object, it'll start from 0 and it lands when the uh, height is 0. So basically, if you equate this as 0, the height as 0, you will find the starting and the ending time. So let us just solve this as mod phi 3, that is negative 4.9, and then we have 49. Now, this last one is 0. Now, let me just solve this. We have got 10 and 0. What does it mean? Now, try to understand over here. We have got this position function. Okay. Now, when the time, when the height is 0, either you will be throwing the object upwards or it lands on the ground. Those are the only two possibilities. Why is it so? Why? Because when you throw, it is starting. So the time is 0. See, time is 0, t is 0, t value is 0 when you start. And when is the t value ending? When it finishes, when it falls down. So you get two values of t, that is 10 and 0. So when we substitute this y of t as 0 and solve it, we got t equals 10 and 0. Now 0 is the launch time basically, and the landing time is 10 seconds. Now basically landing time is the time of flight. That much minutes it was on flight. Now we have to just quickly solve the horizontal component. Horizontal component is not same as the vertical component, because if we go back, we can see, okay, it's okay. V sine theta is the horizontal component, vertical component, whereas the horizontal component is V cos theta. Now here what you need to do is understand that the acceleration due to gravity is only for the vertical. Acceleration on the horizontal component is not mentioned, so basically it's 0. The projectile is has only gravity acting on it. They have not mentioned any other acceleration, so it's basically 0. And then we start solving the velocity. The velocity over here would be integral of this. Basically it's again 0 and plus c, because we have only the constant of acceleration. What is that c value? You can easily find it by this formula. X dash of 0 is equal to v naught cos theta, and then you get that 98 cos theta. Over here you can use the calculator and solve it. We just now did this over here. Use radian mode. Please make sure you're using radian mode, and then you can write 49 root 3, and that, sorry, I'm mistaken. 98 into cos pi divided by 6. So this is it. Now over here you get 49 root 3. Now this one, 49 root 3, is basically the velocity, the horizontal velocity. Now to find the position, integrate this, you will get the answer. There is no, the c value is 0. Now all you need to do is add this time of flight over here. So this is the horizontal velocity, right? If you multiply it by the time, you basically will get the exact horizontal distance. So multiply it by 10, this is your horizontal distance. That is how we solve this. Same concept is used. You need to solve all these by yourselves. The explanations are over here. You can pause it and check it out. Please do solve it by yourself and then check for the answers. If you're getting any doubts, please click on the video link to in the description that has explained entire projectiles lesson. So all this, you can just pause it and check the answers later on. So this is all this. That's it.